In this video, I'm going to talk about type 1 and type 2 error and explain how to calculate sensitivity, specificity, positive predictive value, and negative predictive value. So how I usually like to arrange these tables is to put the disease on the horizontal axis, so people that have it would be positive and people who don't have it would be negative. And then the test results, which is the screening test, would be on the vertical axis. Anyone who tests positive would be plus, and then negative for those who test negative. So on the exam, you may not get this arrangement, and you may have to rearrange the table to put it in this order. So people who have the disease and are testing positive are true positive, and people who don't have the disease and test negative are true negative. And the higher these values, the true negative and the true positive, the more accurate a test is. Now, if a patient doesn't have the disease but tests positive, that would be a false positive, which is known as type 1 error or alpha error. And individuals who do have the disease and test negative would be false negative, which is also known as type 2 error or beta error. So if you have a curve here for individuals who are healthy and another curve for individuals who have the disease, and then let's say we have a screening test with the threshold that is set here. So anyone who falls above the threshold would be testing positive as if having the disease, and anyone who falls under the curve would be testing negative. So here we have certain individuals that are healthy but are testing positive. So this would be a false positive, also known as alpha or type 1 error. And then we have some individuals that are having the disease but is testing negative. So that would be a false negative or beta error. Now the question here is, how does the alpha and beta error change? By changing the threshold of a test. So let's say here we increase the threshold of a test. We move the test to here. So the area under the curve for people who have the disease but test negative would actually increase. So therefore there would be an increase in beta error. And then the area for healthy individuals who are testing positive for the test would decrease. So it would be here compared to what it used to be. So therefore alpha error decreases. So by increasing threshold, alpha would decrease but beta would increase, and vice versa. If you decrease the threshold, alpha would increase and then beta would decrease. Next, I would like to discuss how to calculate sensitivity, specificity, positive predictive value, and negative predictive value. So positive predictive value refers to the number of individuals that are having a positive test and are actually having the disease, while negative predictive value refers to individuals who test negative and do not have the disease. Sensitivity, on the other hand, is a test that will help rule out a disease. So a test that is highly sensitive will have a low false negative rate. And how you can memorize it is that false negative goes for sensitivity. And so if these individuals test negative, since they have a low false negative rate, then you can rule out the disease. And for a test that is highly specific, it would have a low false positive rate. So again, the memory aid for that is positive, low false positive for highly specific test. And so any individual who tests positive, you can rule in the disease in that individual. So next, I would like to discuss how to calculate sensitivity, specificity, positive predictive value, and negative predictive value. And if you actually arrange the table in this arrangement that I've shown you, disease on the top, positive, negative, and then test on the vertical axis, positive on top, negative on the bottom, then it's really easy to calculate these values. So for sensitivity, you will use the first column, and for specificity, you will use the second column. The general rule is that always the green boxes, true positive, and the other green boxes, true negative, they will be always in the numerator. So just keep that rule in mind, and it would be so easy to calculate sensitivity. So here, sensitivity, I said green box would be always in the numerator, so it's equal true positive divided by true positive plus false negative, since we are using the first column. So true positive plus false negative. For specificity, we're using the second column, and again, as a general rule, green box is always in the numerator. So specificity is equal to true negative divided by, in this column, we add false positive plus true negative. For the positive predictive value, we will use the first row. And again, the same rule applies. The green box is going in the numerator. So true positive divided by, if you're using the first row, true positive plus false positive. And then for negative predictive value, we're using the second row. Again, the green box, which is the true negative, goes on top, divided by true negative plus false negative. Alright, now I would like to repeat what I just explained here. So here we will have the disease. On the horizontal axis, anyone who has it would be plus, and anyone who doesn't have it would be negative. And then the screening test on the vertical axis. So here we will have true positive and true negative. The higher these two values, the more accurate the test is. Now, individuals who don't have the disease and have a positive screening test would be false positive, which is also known as type 1 or alpha error. And individuals who have the disease but test negative would be false negative, that is type 2 or beta error. So in this curve, you can see that we have the healthy individuals as a blue curve, and then the disease individuals as a red curve. So anyone who falls above the threshold will be diagnosed as a positive test, and anyone who falls below the threshold would be diagnosed as having a negative screening test. So there are healthy individuals who fall above the threshold. So that would be a type 1 error or false positive. So this is a false positive. And then people who have the disease but fall below the threshold would be beta error, which is false negative. Now, by increasing the threshold of the test, the area under the curve that corresponds to type 1 error or alpha error decreases, while the area under the curve that corresponds to the beta error will increase. So that would be like this. So therefore, by increasing threshold, beta error will increase while alpha error will decrease. Likewise, if you decrease the threshold, so let's move back the threshold from here to here, then the area under the curve that corresponds to type 2 error or beta would be less than before. So here would be decreased beta, and then the area under the curve for healthy individuals that test positive would be much higher than before. Would be like this. So it would be increased alpha. So exactly reverse of what I just explained earlier. Next, I would like to go over on how to calculate sensitivity, specificity, positive predictive value, and negative predictive value. So here we will have the disease, positive, negative, and here we will have the test, positive, negative. So again, I would like to remind you that you may not get this arrangement on the test and you may have to rearrange it yourself. So the two boxes that are important are true positive, which is right here, and true negative, that is here. For calculating the sensitivity, you will use the first column. So it's equal the green box, A, divided by the first column, you will use A plus C. For specificity, you will use this column, which would be the green box, D, divided by D plus B. For positive predictive value, you will use the first row, but still the green box will be in the numerator, so it equals A divided by A plus B. And for negative predictive value, you will use the second row. Again, the green box, which is D, goes in the numerator, divided by D plus C. And finally, there is one other value, which is called accuracy of a test, which corresponds to all the green boxes, which is D and A. So D plus A divided by all other values, A plus B plus C plus D. So the higher the true negative and true positive values, the more accurate the test is. And that concludes our discussion.